Everyone. This is the third and final page of the Chapter 9 portion of the Algebra 2A exam review, starting here with number 10. So number 10 tells us this funky looking triangle has an area of 1 square meter, and we need to figure out what x is. So let's first figure out where that 1 square meter would have come from. The area of a triangle is 1/2 base times height. Okay, so I would plug in what we know here. My area is 1, so I'm putting a 1 in for A. So this is 1/2 times base, which really this big long side is my base. That's 3x plus 2. And my height is that teeny tiny x minus 1. Okay, and now I'm just solving for x. So what I would do realistically, so that I don't have to deal with this 1/2 and all the 0.5s and everything, is I would start by multiplying by 2 on each side, because that's going to get rid of that 1/2. So I'm going to say 2 equals, and then here, actually I don't even need the parentheses there, sorry about that. So I got rid of the 1/2 by multiplying by 2. Now I'm going to FOIL these two things together. Okay, so 3x times x is 3x squared. 3x times -1 is -3x, and then I have a 2x. So I have -3x and 2x, which makes -1x. And then 2 times -1 is -2. Okay, this is kind of looking like a quadratic. What I'm going to need to do now is subtract this 2 on each side to make this thing equal 0. So I'm going to now make this be 3x squared minus x. And then I'm subtracting the 2 from over here, so that's really going to turn that into a -4 equals 0. From here, I'm going to use the quadratic formula. Okay, so this is a quadratic formula, ax squared plus bx plus c. So in my calculator, I'm going to pull out my quadratic formula here. A is 3, b is -1, and c is -4. Okay, and I get that x could be 1.3 repeating is 1 1/3, otherwise known as 4/3. If you would put 1.3, that's okay too. I just don't like repeating decimals. Or x equals -1, okay, from the quadratic formula. The problem here is that if you think about it in terms of the situation, -1 does not make sense, because you can't have -2 as a side length. Okay, you can't have, let's see, that would be -3 plus 2, so that would be -1 as a side length. Okay, so I'm going to eliminate this one as a possibility just because it's negative, and then I'm going to say that this is my answer, that x is 4/3 or 1.3 repeating. Okay. Okay, number 11. We've got a polynomial there in factored form, and we're going to be talking about some multiplicities here. So what 0 has a multiplicity of 4? Well, I see a multiplicity of 4 right here, where I see 3x minus 2 to the 4th power. What I want to know, though, is what is the 0 that goes along with that? This is a factor. I want the 0. So to get the 0, I'm going to say 3x minus 2 equals 0. And then I'm going to add 2, divide by 3, and I end up with x equals positive 2/3. So what that means is if I plug in 2/3 for x, that's going to make this thing equal 0, right? And if this thing equals 0, then it wipes out everything. Everything is being multiplied, so that would give me an overall answer of 0, which is what it means when I say that this is a 0. Okay? Now, what is the degree of f? And I have a lot of people with this question always wanting to just look for that biggest exponent. But remember that all of this is really being multiplied together. If I really wanted to answer this question thoroughly, I would multiply all of this out. Now that's going to be gigantic and terrifying. But I think that we can figure out what the degree is without doing that. We can just think to ourselves, if we end up multiplying all of these x's together, here's like an x. This is going to end up being an x squared. So there's 1, 2, 3. This would be x to the 4th. So I would have 4, 5, 6, 7. And this is going to end up being an x to the 5th. So 8, 9, 10, 11, 12. So my degree is 12. Okay. And really what I did there was I added up all the exponents. Okay. Because if they're all being multiplied together, eventually they're going to get combined through addition. Okay. And that would be my highest exponent, would be a 12. Now, how many x-intercepts does the graph have? We've always told you that x-intercepts and zeros are really the same thing. The one minor difference is that even if this has a multiplicity of 4, it's still only crossing the x-axis one time. It's still only hitting once, okay? So in terms of x-intercepts, I'm just looking at how many distinct zeros would I have. So I would have 1 here. I would have 1 here. It would have a multiplicity of 2, but that would still just be 1 intercept. I would have 1 here, and I have 1 here. So I would have 4 x-intercepts. And then I'll just say this is the number of distinct zeros. So if we included all the multiplicities, I should be able to come up with 12 zeros, right? Because that's my degree. But there's only going to be 4 different ones because so many of them are going to have multiplicities. This would be a multiplicity of 4, this would be a multiplicity of 5, and so on. Okay. Now, I think I had you skip number 12. We could do it, but I'm not going to take the time to do it right now. Maybe I'll come back and do a separate video on number 12 if we need it, but you don't need it for your exam. Let's look at 13. An equation in standard form with these zeros. Okay, the thing you have to keep in mind when it lists out your zeros is that complex roots come in pairs. So as soon as I see 4i on my list, I'm going to add negative 4i to my list as well. Okay? Well, if these are my zeros, then I can turn each one of my zeros into a factor. So x minus negative 3 would really be x plus 3. Okay? And I'm going to go a little bit out of order because I like keeping my reals and my imaginaries separate. So this one here would really become x minus 1/5. Let's write this up here. X minus 1/5. But we don't want to leave it like that with a fraction. This is one where I'd want to take that denominator off and put it over here. And I'd really call it 5x minus 1. And again, the reasoning behind that is if I were to set this equal to 0 and solve it, the answer would come out to be 1/5. Okay? And then I'm going to do x minus 4i and x plus 4i. Okay? And that comes from the 4i and the negative 4i. Okay, now the thing is, it wants this in standard form. Standard form means I need to multiply this whole thing out. So what I'm going to do is I'm going to take these two and FOIL them, and these two and FOIL them. And then I still have some more multiplying to do after that. So let's see, this is going to give me 5x squared. See if you can follow me here. Negative 1x plus 15x is going to give me 14x. And then 3 times negative 1 gives me negative 3. Over here on this side, I'm going to get an x squared. Now, watch what's going to happen here. I'm going to end up with 4i times x. But then I'm going to end up with negative 4i times x. And those are going to cancel each other out. That's what happens when you have conjugates. These are conjugate pairs. Okay? So my outer and inner cancel out. And then negative 4i times 4i really gives me, let's see, put this up here. It's going to give me negative 16i squared, which we're smart enough to know that that I squared turns that into a negative 1. So this is really x squared plus 16. Okay. Now I need to multiply these two things together. So really no way around it. We just have to do a lot of distributing. So 5x squared times x squared makes 5x to the 4th. 5x squared times 16, let's see, 5 times 16 is 80. So that's going to give me 80x squared. Now I'm going to go, so I did these two. Now let's do 14x times x squared, so that's 14x cubed. 14x times 16. Oh, I'm going to need some help with that one. 14 times 16 is 224. Okay, and that would just have an x on it. And then we're going to do negative 3x squared. And negative 3 times 16 is negative 48. That's actually, excuse me. Okay, and sorry I had to go on to 2 lines there. Didn't mean to put that little guy there, but now I'm just combining like terms. So I'm going to say I have 5x to the 4th. Standard form means I want my exponents in order. So next I want to go with my x cubed. Then I'm putting my 2x squared terms together. So that would be 77x squared. Okay, use those, I use those. Here's my x, 224x, and then minus 48 down here at the end. And that would be my equation in standard form. And if you wanted to check it, you could graph this thing. I don't really want to take the time to type all that in right now. I could graph this thing and check to see that it crosses at these. Well, you're going to be able to see these two, the negative 3 and the 1/5. You won't be able to see the imaginary ones. Okay? One last one real quick because you guys are on your way in. Factoring something like this, I'm going to pull out the GCF, which is a 2, and then they have 2 x's in common. And that's going to leave me with an x squared.
Students, please report to the main office.
So what I'm really saying here, sorry guys, x squared times x squared is x to the 4th, and then there's your 2, minus, and then 2 times 9, okay, because 2x squared times negative 9 would give me negative 18x squared, okay? So I pulled out my GCF. This here is a difference of 2 squares. Okay, which means this factors as x plus 3 and x minus 3. And then I'm just going to pull this 2x squared down in front. And that would be completely factored. Okay, that's it for Chapter 9. Hopefully that helps some. If you do have questions, of course, you're welcome to ask in class. I'm happy to help.